We're going to look at Newton's second law of motion and how it explains the ways things move. In this lesson, we'll talk about what force is, about the relationship between force, mass, and acceleration, and we'll talk about Newton's second law of motion, both in words and in an equation. We hear the word force all the time, but we seldom stop to say what it means. A force is an interaction between objects that causes a change to the object's motion. Forces have a magnitude, which means how strong they are, and a direction. In simpler terms, we could say that a force is some kind of a push or a pull. Like most other properties in physics, force has its own unit. The unit we measure force in is called the Newton. And a Newton is abbreviated with a capital N. Newton's second law of motion says that the acceleration of an object is directly proportional to the force applied, and the acceleration is inversely proportional to the mass of the object. You may be familiar with those terms from math classes, but let's review. Newton's second law tells us that the acceleration is directly proportional to the force. You may remember from math class that when two things are directly proportional and one gets bigger, so does the other. That means that if our acceleration gets bigger, then the force must be getting bigger also. This also means that if the force gets smaller, then the acceleration has to get smaller too. Newton's second law tells us that acceleration is inversely proportional to mass. When two things are inversely proportional, that means when one gets bigger, the other one gets smaller. So if our acceleration gets smaller, the mass must have gotten bigger. On the other hand, if the mass gets smaller, we know that the acceleration has to get bigger. Newton's second law of motion is usually seen in its equation form. Acceleration equals force divided by mass. But there's another form of the equation that's very common also. If we multiply both sides of the equation by mass, you can see that mass cancels out on the right-hand side, and that leaves us with the equation force equals mass times acceleration. Both versions of this equation are very useful in different situations. You should make sure that you have both equations in your notes. Let's try an example problem. John's car produces 550 newtons of force. The car's mass is 2,200 kilograms. How fast can John accelerate? Let's remember to use our cues. Every time we do a problem in physics, we write down our knowns and our unknown. We write down the equation we're going to use, substitute in the values, and then show each step to solve. We see in the problem a force of 550 newtons is given, a mass of 2,200 kilograms is given, and the problem is asking us how fast John can accelerate. We can use cues to organize our knowns, our unknown, and our equation that we know we're going to use to find acceleration. Substituting our knowns into the equation, we get acceleration equals 550 newtons divided by 2,200 kilograms. Now we just need to solve using our calculator. We find that John's car can accelerate at 0.25 meters per second squared. That's pretty slow. I think John might need a new car. Let's try another one. SpaceX's Falcon 9 rocket has a mass of 549,000 kilograms. When the rocket is accelerating at 12 meters per second squared shortly after liftoff, how much force are the Falcon 9 engines producing? Looking in the problem, we see some knowns. There's a mass of 549,000 kilograms, an acceleration of 12 meters per second squared, and then the question is asking about how much force the engines can produce. Setting up our cues, the mass and acceleration are knowns, while the force is our unknown. For our equation, we could use acceleration equals force divided by mass, but we'd need to do some algebra to rearrange it. Since we already did that, Let's just put in the equation for force. F equals ma. Substituting the numbers, we see that force is 549,000 kilograms times 12 meters per second squared. Now all we need to do is take a calculator and do that multiplication. Our answer is that the force of the rocket is 6,588,000 newtons. In this lesson, we've looked at how greater force means greater acceleration, but greater mass means less acceleration. We've seen that Newton's second law describes the relationship between force, mass, and acceleration. And we've seen that force equals mass times acceleration. We also practice problems using the force equals mass times acceleration equation and our Q's format.